Alright guys, so today we're going to take a look at complex numbers and polar form. So we'll come back to polar form in a little bit here, but let's talk about complex numbers, okay? So we have some complex numbers here, nothing crazy, right? We reviewed these the day before, okay? And so when we have something like 2 minus 3i, you might think to yourself, okay, that's a complex number in standard form, a plus bi, right? Could I graph that? Now, most of you probably have never asked yourselves that question ever, 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 which is okay. I can accept that. All right, but today we are going to answer that question. So, how would you graph something like 2 minus 3i, right? What would you do with this if you wanted to graph it? Well, the problem lies not with 2 minus 3i, the problem lies with our graphs. Okay, we have an x-axis, we have a y-axis, and the problem is that they're both real numbers on those axes. And so how could I put something like an I on one of our axes? So here's what we're going to do. Instead of having an x-axis and a y-axis, we're going to have a real axis and an imaginary axis. So the real axis is going to have real numbers on it. So like 0, 1, 2, 3, 4, and 5. And going the other way, -1, -2, -3, -4, and -5. And as always, you're going to forgive my god-awful handwriting. Alright, now the imaginary axis is going to be very similar, but it's going to have one eye going up the axis. So right here, that is going to be one eye. Right there, that is 2i. Going up, 3i, and so on and so on. Okay, and we can have the same thing going down. We can have -1i, -2i, -3i, and -4i. Okay, so now let's go ahead and graph. And the way we're going to graph these is going to be like an old favorite of ours, vectors. Okay, so let's start off with 2 minus 3i. So we're going to go 2 over on our real axis, and then we're going to go down 1, 2 to 3i on our imaginary axis. And so let's zoom in right here, and let's go ahead and graph 2 minus 3i. Alright, next up, I'm going to switch colors here. We had 1 plus 3i. So we're going to go over 1 on the real axis, up 3i on the imaginary axis, and that is going to take us up right there. So there is 1 plus 3i. The next one we have is what? 4 plus I? And so that is going to be 4 on the imaginary axis, up 1 on the real axis, and we get 4 plus I. Assume I know how to write a 4 correctly. Alright, so I think we get the hang of this, okay? And then, actually, let's do one more for funsies here, okay? Let's do 5i. So 5i is just going to be straight up the imaginary axis to, let's see, right about there. And that one is 5i. Okay, so straight up there. All right. All right. So Graphing complex numbers, not terribly difficult. Okay? Now, let's see what we can really do with complex numbers. Let's say we had some complex number on our graph here, and it was x plus y times I. Okay? So that means we go over x units on the real axis and y units up the imaginary axis. So let's say that took us to, I don't know, somewhere right there. Okay? And so that gives us something like that, right? And so what I'm going to do, and what we always love to do, is to make a triangle. Okay? And I went over x, and then I went up y. So the hypotenuse of this triangle, we're going to go ahead and call r. That's an old favorite of ours, okay? And then what we're also going to take a look at here is the angle formed from the positive real axis up to where the hypotenuse is, and that angle is our theta. You're going to ignore the fact that I can't draw a proper theta. Okay, so now I can go ahead and say a few things based off of this picture, okay? The first thing is I can say that our r is equal to the square root of x squared plus y squared. That's just good old Pythagorean theorem, nothing crazy with that. The next thing I can say is that the tangent of theta and that time I drew a decent theta, messed up the y, that's okay. I can say tangent of theta is equal to y over x. Now, I can also go ahead and say that the sine of theta and cosine of theta, I can go ahead and find those two things as well. Sine of theta is going to be y over r, and cosine of theta is x over r. Now, perfectly honest here, I don't really care about what sine and cosine are. But what I can do with these is I can go ahead and solve for x and y. So y is going to equal r times the sine of theta, and x is going to equal r times the cosine of theta. Okay? And so this gives us four really important formulas here, all of which really aren't new, right? So our first formula here is just Pythagorean theorem, and the other three are just some basic right triangle trig. Okay? So nothing crazy going on here from this picture, right? The only difference here is that, now we have a real axis and an imaginary instead of an x-axis and a y-axis, okay? So, what are we going to use all of this for? We're going to use this for finding the trigonometric or polar form of a complex number. So, let's go back to x plus yi. Okay, good news, everyone. That was my professor from Futurama. You're welcome. That'll never happen again. Regardless, what we can do now is we can take our values for x and y and we can sub them into our complex number. So we can rewrite this as r times the cosine of theta plus r times the sine of theta times I. And what we can do here is we can go ahead and factor out an r from this and get r times the cosine of theta plus I times the sine of theta. And this beauty right here is how you write a complex number in polar form. So, one really important thing here, right? We took the I value here and we just go ahead and plug it before the sine of theta, just so there's no confusion on whether or not we're taking the sine of theta times I, which sounds like a whole lot of trouble. Okay? So, how do you write a complex number without knowing how far over on the axes you go? You can talk about it in terms of the length from 0, 0, right, or 0 plus 0I to the endpoint, and then the angle that's formed going up from the positive x-axis, r and theta. Those are our values when talking about polar form. Okay? Now, we can also take this and we can actually shorten this down into a very nice form, which is r CIS theta. R CIS theta. Okay? So this is the shortened form for writing a complex number in polar form. Okay? By the way, R CIS theta, the worst CBS cop procedural. Okay, no more jokes, I promise. Alright, so there's our little introduction to polar coordinates. Alright, we're using R and theta instead of using X and Y. And we can go ahead and plug that into standard form of a complex number. And we get these two beauties right here. Okay? Alright, so now let's go ahead and do some practice. Okay, so the first thing we're going to do is we're going to convert from trigonometric or polar form into what is called rectangular form. So rectangular form, I guess we should also note this, rectangular form is our standard x comma y form. Or in this case, since we're talking about a complex number, it is x plus yi. Okay, so we're starting with a complex number here in polar form. 2 times the cosine of 300 degrees plus I times the sine of 300 degrees. Okay, now real quick, before we go ahead and convert this, let's just see what the heck this is saying. Okay, let's graph this. Oh, we love a good graph. Alright, so we're going to go counterclockwise 300 degrees. And so that is going to be something like that. And then we're going to come out and have an R value of 2. And we went 300 degrees. Okay. Now, this also helps us get a picture of, what the rectangular form should be, right? So just based off the picture, we can tell that x should be positive, y should be negative, right? We're down in quadrant 4. Okay. You also probably could have figured that out just by looking at the angle. Okay, but I like the graph. Alright, so we're not really here to graph, okay? Let's convert this to rectangular form. Now this is actually going to be pretty simple, okay? The first thing we got to do is we got to know our unit circle. So maybe it's not going to be that simple for some of us, but hopefully it will. Alright, so this is going to be 2 times the cosine of 300 degrees is going to be 1/2 plus I times the sine of 300 degrees is negative root 3 over 2. And we're going to distribute. We're going to distribute. And so this is going to become 1 minus I root 3. And that is our complex number in rectangular form. Alright, so let's do the same thing for 6 CIS 135 degrees. One thing that I don't think will hurt you to do is you can take this and go ahead and just rewrite it back into the long form. So this is going to be 6 times the cosine of 135 degrees plus I times the sine of 135 degrees. So this is going to be 6 cosine of 135 is negative root 2 over 2 plus I times the sine of 135 is positive root 2 over 2. Distribute, distribute. This becomes negative 3 root 2 plus, and now you got to be careful with this how you want to write it. The exact way to write this is a little bit weird, okay? This is going to be 3I root 2. Okay, so kind of the accepted formatting here is you kind of smush the I in between the constant, or excuse me, between the whole number and the radical. Okay, now if you wrote 3 root 2 and then put the I outside the radical, I would still accept it. You would just never see it written that way anywhere, basically ever. Okay, alright, so going from trig or polar form back to our standard form, right, x plus yi, not terribly complicated, okay? Going the other way, however, this could be a little tricky, a little tricky. All right, so let's take a look at that. Okay, so negative root 3 plus I, this is our standard form, right? And so this means that x equals negative root 3 and y equals 1, right? X plus yi. Okay, so now we need to figure out two things in order to write this in trigonometric form. I'm going to zoom in here. Okay, so trigonometric form involves two pieces. I need an r and I need a theta. Okay, so those are the two things I want to figure out. Now, very good for us, earlier, right, we had formulas for finding r and theta. Huh, isn't life great? So, let's use those, okay? So, we said that r is going to equal the square root of x squared plus y squared, right? Because r was the hypotenuse of that right triangle. So we do a little bit of that, Pythagorean theorems and the what's nots, and we're going to get that r equals 2. Okay? Finding r, not terribly difficult. Okay? Alright, now, we don't necessarily have a formula for theta, but we did earlier have that the tangent of theta was equal to y over x. So in that case, this would be 1 over negative root 3, which we can go ahead and rationalize to negative root 3 over 3. Okay? So now, let's think about this. Okay? We need an angle theta that has a tangent value of negative root 3 over 3. But there's something very important here, okay? Because remember, infinitely many answers, right? Here's what we know, okay? X was a negative number, y was a positive number. X is negative, y is positive. That's going to be super helpful because that is going to tell us that our theta is most definitely going to be a quadrant 2 angle. Okay, so it's important to establish that so you don't get your theta from the wrong quadrant. All right. Now we're just going to stick to values from 0 to 2 pi just to make our lives easier, mainly my life easier. Okay. So now let's think about this. I need a theta value in quadrant 2 that gives me a tangent of negative root 3 over 3. And if we think here, we use our wonderful gigantic brains, I think we're going to come up with 5 pi over 6 for theta. Okay, so we got our R value, Pythagorean theorem. We get our tangent, or excuse me, we get our theta by using tangent. And so now let's put R and theta together to write the trigonometric form of this complex number. All right, so that is going to be R times the cosine of theta plus I times the sine of theta. And that will do the trick. Or we can go ahead and use the shorthand form, the cis form, which is R CIS theta. Okay, so either of these, the longhand form or the shorthand, completely acceptable on a quiz or a test. Okay, but both of these are the polar form of our complex number that we started with. All right, let's do one more of these. Okay, negative 3i. Is negative 3i a complex number? I don't know. Is it? I don't know. Can my pitch get any higher? I don't know. Regardless of that, negative 3i is a complex number, right? I can rewrite this as 0 minus 3i, right? So the real part is 0. That's going to be my x. And my y part is just going to be negative 3. And so we need the same two things. We need r and theta. So r is going to equal the square root of x squared plus y squared. And so r is going to be, square root of 9. R is just 3. Yay! All right, let's talk theta. The tangent of theta is going to be y over x. So that is negative 3 divided by 0. Now, some of you might be thinking to yourself, that is undefined. Okay, so we need to find a theta value that has an undefined tangent. Okay, but it's also worth noting that, again, y is negative. Now, in this case, x is neither positive nor negative, which means we can't bring this into a specific quadrant. However, if x is 0 and y is negative, doesn't that mean we are on the negative part of the y-axis? And so that what goes ahead and tells us that theta has to be 3 pi over 2. Right? We would have a negative y, and x that's 0, and that would make its tangent undefined. So 3 pi over 2 is the only angle that works here. Okay, and so let's go ahead and put this together. So our polar form is going to be 3 times the cosine of 3 pi over 2 plus I times the sine of 3 pi over 2. And that is one way to write our complex number in polar form. And the other way we can do this is the shorthand 3 CIS 3 pi over 2. Okay. All right. And so just a quick note with this one, okay? For this problem, you really don't have to show all of this work. All right? Because another thing you could have done is you could have just taken a second and just visualized negative 3i. Okay? So the work here is amazing, right? Obvs, because I did it. But let's just take negative 3i real quick and do our favorite thing, and let's just graph this bad boy. So negative 3i, if we were to graph it, and assume I can draw things well, negative 3i would just be straight down the imaginary axis. So let me zoom into this here. Again, you're going to assume I can draw. Okay, so negative 3i is right down here. There's that complex number, negative 3i. Okay, so now let's just take a look at this thing, right? So just by looking at this, it obviously has a length of 3, and if I just try to measure this angle, I can very clearly see it would have to be 3 pi over 2. Okay, so if you get something like this that is on the axes, right, doesn't matter which part, okay, draw a quick picture, figure out your r and theta, easy peasy. Okay, all right, so that's all we have for today. Okay, your homework is to write a 7-page paper on why this was the greatest day of your life. Okay? Random zoom ins. Alright, we're done.